Welcome to Steamworx. I'm Tim. This is Tim's Top Tool Tips. Many machine tools use ball handles. This is from the tool post of my lathe. This smaller one is left over from making the George Thomas Universal Pillar tool. Ball handles are strong and are pleasing on the eye. They're also got a very nice feel to them. These are from the tool and cutter grinder. They can come in a variety of forms. I make ball handles in the lathe from a piece of round bar. To begin, slots are cut at each end to allow the ball to be formed. A mechanism is then required to move the cutter in an arc to form the ball. Once the ball profile is complete, the centre can be removed to form the handle. This is the tool I'll be using to cut the profiles. The first thing we're going to need is a cutter. This is a 1/4 inch diameter high-speed steel tube blank. I have a tool and cutter grinder, but it's easy enough to freehand this on my bench grinder. I grind a flat at about 22 degrees to give the correct rake. If I leave the tool round, we'll get a large fillet between the left-hand side of the ball and the handle stem. I grind half the tool away to prevent this. It's nice to have a good pen mark as a guide. It's a bit cheap and cheerful, this grinder. The wheels are all over the place. It's on my list of things to do, another project for later. With the basic shape formed, the edge is rounded using a diamond file. Because of the tool geometry, I can use the tool holder as a honing guide. This allows me to repeatedly sharpen this tool accurately. It just takes a few rubs to remove the grinding marks. It's important to accurately position the tool so its centre point rotates around the centre of the ball that you're going to cut. As an aid to this, I've decided to make a pointer so that I can position the tool bang on the centre line of the ball. When making the tool, I added a centre hole for exactly this purpose. The compound slide is set over at 15 degrees to give a nice pointer. And of course, make sure to remove all sharp edges, apart from the point, that is. Now we can prepare the steel. The outer diameter is made to the outer diameter of the ball. Then we need to mark the radius and the diameter of the ball, plus the amount that we want to remove to form the slot for the cutter to fit into when we do the left hand side of the ball. Next we'll remove material to form the slot. The slot needs to be wide enough to allow the diameter of the tool to pass freely. The slot is cut to a depth such that the material left is equal to half the diameter of the ball. Now I can set up the ball cutting tool. With the center point in place, as you can see it's revolving around the center of the tool. The tool needs to be brought to center height, otherwise you're going to turn a rugby ball shape. Then we can position it at the center of the ball that we're going to turn. Then with the setting pin removed, we can put the tool itself on the center. Cutting the ball itself is quite an easy job, just rotating the tool around the blank. As each cut is complete, the tool is advanced until the ball is finished. Now it's clear to see why the left-hand part of the tool has been ground away. I'm looking for 5/8 of an inch here, and the indexing allows me to get quite accurate. The other ball's done exactly the same way, just slightly bigger. Here I'm just removing the bulk of the waste from the stem. To machine the stem properly, we need to hold the ball securely, and this is going to need a collet. I've made this one from steel, but brass would do. The inside diameter is bored for a good fit to the ball. The depth of the bore needs to be sufficient so it can hold the ball handle securely. So the collet can go back reasonably accurately, I make a centre point mark opposite number 1 jaw. course, for it to be a collet, we need to cut away some of the sides so that it can be closed up. Of course, you can do this in the mill, but I've thrown enough of these across the workshop to realise that sewing and filing, yeah, that's good enough. After removing all the burrs, it goes back in the chuck, and it's a surprisingly good grip on the ball. I have one of these interchangeable live centres, and I made a cone centre to fit it. With good support on either end, we can finish the ball handle. The included angle of the stem is about 2 degrees, so I set the compound slide to suit. I also ground this long-nosed round tool to help with reach. Surplus materials machined away, keeping an eye on the angle of the stem and adjusting if necessary. So that's it, ball handle done. But it's no good like that, is it? You need a hole in it so we can use it on something. And that's where we have a cutout in the collet. The handle can be articulated so that the shaft can be pushed against the edge of the chuck. Checking for clearance along the edge of the bed shear, we can then face the end. The end can then be drilled through or drilled blind, depending on what you need. And that's it now. Job is done.